Hello friends, welcome to Joy of Life. So today we are back with Leetcode again. Another medium level problem. Problem number 139. The name of the problem is word break. So it says given a non-empty string S and a dictionary word deck containing a list of non-empty words. Determine if S can be segmented into a space-separated sequence of one or more dictionary words. There's some additional note. The same word in a dictionary may be reused multiple times in the segmentation. You may assume the dictionary does not contain duplicate word. That's fine. So if we have there are some examples over here. Let's look at it. We have a word like Leetcode, and we have a word leet and code separately in the dictionary. Then we can form the word Leetcode. We can segment it. We can segment it right over here. Leet being one of them and code being the other one, and both are present in the dictionary. Similarly, there are a few other examples. So let's look at them. So here we have another example. Apple, pen, apple, and we have the dictionary apple and pen. So we can segment it over here, apple, pen, and apple. So we can reuse the word multiple times. So apple has been reused multiple times. So one more example wherein we can't do over here. So here we are given with cat, sand, dog. So we have cats, dog, and sand. So if you take this example, so we have cats and dog. So in the dictionary we have cats, dog, and sand. So if I take cats from the first one, then we are left with AND, DOG. So if we take AND, we are left with OG. We cannot use it. And if we take DOG, then we are left with AN. And if we take sand, then we are left with cat and og. So we cannot segment it. We cannot partition it at any portion of the string. So you can see here that cats can be taken. In that case, we are left with and. We cannot do. If I come from the other way around, if I take dog, then we have sand, not sand. So if dog is taken, we have just sand. So we cannot form this. So in this case, we have to return a false, as we see here. But in the other case, we return a true. So we'll look at the solution, and as I always recommend, before we look at the solution, I would highly recommend you that you try to do it yourself. And you can pause the video and then you can resume back once you give it a try. So we'll see how we can get the solution. So let's get the input here. So let's try with apple, pen, apple. So let's get the input over here. So here we have our input and we have the dictionary, and we will see how we can solve this. So since this, let's look at the parameters given over here. So you can see here that we have been given with a string, and we have been given with a list of dictionary words. And as you can understand that we have to do a very fast lookup over here, right? So what I'm going to do is first is we will go with a recursive solution in order to process this. So what I'm going to do is we are going to first create a set and put all the words that we have inside the dictionary into this hash set, so that our lookup is very fast. So that we can have a lookup of the thing very fast, and then we'll take our input. So what we'll do into this recursive function, say we call it func. So we'll start iterating this string, and we will start from index 0 and all the way will go towards the right. So let's start with index 0. When I am at index 0, I'll try to get only that part of the substring, that is A. And look into my set. So there is no A in the set. Then I increments to 1 and I get AP. I look up into the set, I get nothing. I equals to 2, we get APP. I equals to 3, we get APPL. And I equals to 4, we get APPLE. So this is the moment where we see that this word is contained in the set. So what we are going to do is we are going to call this. So as you can see that we have started traversing from here and we have found a match at this point. So we are going to call the same function. Okay, we are going to call the same function, but this time we are going to call it with pineapple, the remaining part of the string. So I start from 0 again, I get a P. I increments to 1, we get a PE. I increments to 2, we get a pen. And again we see that the pen is inside the set. So we call the same function again, and this time we call it with just apple. So what happens is now I equals to 0, again it goes through the same thing. I'll go a little fast here because you got the logic that what we are trying to achieve over here. And when I reaches 4, we get the word apple. And again these words are in the dictionary. So what happens is we store so basically let's check what they want. So they want us to return a boolean. So we return a true in this case because the string length has reached 0. Similarly, we will see the corner case example that we have seen earlier. So here let's talk about apple pen apple before we move on to other example. So what happened here is that I called my recursion using apple pen apple. So on the first recursion, what happened was apple was taken and pen apple was passed, right? And then pen was taken and then apple was passed. And then nothing was passed. It was a happy path. It was null. And we got a true from here and we returned it. So now in this case what will happen is cat, sand and dog. So I will not go into this kind of charting for this approach. Rather I'll show you what happens to the tree. So when I start parsing cat, sand and dog, so let me put it cats and dog. So cat is taken first. So I start from the left and I get a cat and I pass sand OG into my next recursion. And then I have a matching on cats as well, CATS. So what happened is I pass and dog. Right? So these two are passed. Then there is no match because there is no bigger word that starts with CATS into my set. So what happens from this part of the recursion is sand is taken. So S is checked first, then SA is checked, then SAN is checked. SAND is a match. So sand is taken, OG is passed. Okay. And what happens in this part of the recursion? OG is never found on the set, and a false is returned from here. And what happens in this case? It tries for it tries for A, then AN, then AND. It gets AND, and OG is a passed again. So the next match that I could get is a AND, right? That is over here, AND, and a false is again passed. So both the side of the tree propagates back a false. So false is passed all the way. and our final result becomes false. So this is how the entire algorithm works. So every time we try to see, try to start scanning from the left and see what are the possible words that we can identify that is present inside the set, and the rest of the string we pass it on to check again. What we're going to do is we are going to quickly look at the code. So the code for this is pretty simple, as I told you, right? So we are going to create a set of string for faster lookup. So I am going to call this my dict, and okay, one more thing that I wanted to add over here. So you might see that we might be traversing the same string over and over again. So what I wanted to introduce in this problem is that when we are getting a result, we should be using memoization. So it is a technique used for faster computation. So when I have a result, I know that for a particular string, say XYZ, the answer is false. I should store that, and whenever I get the string again in future, I could return directly without processing it. So for example, we have seen over here apple, pen, and apple. So apple is computed twice, right? And we could save on it. So as you can see, for apple, if we don't store it, so what happens is we try with A, we try with AP, we try with APP, we try with APPL, then we try with APPLE. But if I know that the word is apple and it is already present in my memory, pre-computed, I can I can directly use it. So I should cache my result whenever I get a result. So what I am going to do is I am going to create a map as well of string and boolean, wherein I should be able to store the pre-computed results. So here is my dictionary and my cache wherein I am going to look. And now what I'll do is for string word in word dict. So I am going to take all these words and put it back into my dictionary. So what is the benefit basically for doing this is, since we have a limited time and we need to improve on our performance, what I'm going to do, I could have searched in the list as well, but in a set, searching is much faster. That's why I'm just putting all this word into the set. So now I have my function, and return is segment possible. So this is my function. This is going to be my recursive function that is going to tell me is segmentation at all possible or not. So I am going to pass in the string that I am receiving as an input, and I am going to pass my cache in the new dictionary, and cache. So I am going to say is segment possible, and I take a string S. Dictionary is nothing but a set of dict, and I have the cache, which is a map of string boolean, and let's call this a cache. Okay. So what I am going to do, so whenever I get a word, whenever this is the word that I get, so I should first go and check if cache dot contains key of S. If it is there in my cache, then I don't need to do anything. I can simply do cache dot get of S. So when I am looking for a string, if that string is already present into my map, I am just looking up and returning the pre-computed length. Okay, now the second important part is when my string dot length is 0, that means when I have a case like this wherein I am passing null, nothing, an empty string, at that point of time also I know that I have found a match. There is no more string that is present, unlike OG over here where we could not find a match. So this is another condition wherein we will say that we have got the match and we will be returning a true from there. Okay, and then we are going to get our result. So I am initializing this boolean string with false, and then as I told you that I am going to iterate over my main string. So we're going to traverse the string starting from the index 0, and at every step we are going to create a new string. And what we are going to do, we are going to do a substring. So basically what we are doing is, first we take only the first character, that is 0 starting from I plus 1. So 0 to 1, then 2, then 3, then 4, then so on till the end of the string. And each time we get that string. So first time for apple, pen, apple, we get A. Second time in this loop we get AP, then APP, then APPL, then APPLE, and so on. So what we are going to do, if my dictionary contains the word str that we are looking for, that means we have managed to find the match that we are looking for, and we are going to call the is segment possible with the rest of the string. With rest of the string. So when we say rest of the string, that means what we are passing over here is s dot substring, and we are passing from I plus 1. So here if you notice that we have ended at I plus 1, so 0 to 1, and here we are passing 1 to the remaining, not 1, means when I get apple, when the word apple is matched over here, then this will return me pen apple. So we'll pass pen apple to the recursive function. And what else to do? We pass the dictionary and cache as it is. There is no modification to it. Now whatever we get out of this recursive function, we need to get into the result. And if you notice, I have initialized result with a false. So if I do a result or and then followed by the call to the recursive method, that means whenever we get a true, so if it is initialized to false, and if I get a true from here, it becomes true. So if I get from any of my recursion branches, if I get a true, so my result become true. Result for any of the operations, we need to store that result in this cache. So we know for S we have found the result, and the result should be cached. So we are putting the result here, and we are going to return whatever the result is. So when I try with apple, when apple is tried, pen apple goes to the next recursive function. Then pen is matched, and apple is going to the next recursion, next level of recursion, and then finally nothing is passed. So this condition is met, and the true is propagated back. So when I get a true from apple and from apple, pen, apple, I store that into my cache. So whenever I see apple again, I do not need to go to this route. I can directly say that apple, when I get only the string apple, it means there is a matching or not matching. I know directly from my cache. So let's run this code and see. So you can see here that it has been accepted. So let's submit for a broader range of test cases. So yeah, it has been accepted with 6 milliseconds, which is better than 64.86%, which is okay, not bad. Definitely there is a scope for improvement, and I highly recommend you try to optimize this code. So basically, the main intention for me was to give you an idea on how this recursion tree is formed and how we are propagating the result back from the chain. So I hope you liked and understood the concept. If you have liked, then do share it with your friends as well. If you, please subscribe if you haven't done so, and definitely keep visiting my channel. I try to create as much content as possible. I try to go as deep as possible in order to get the solution. So thank you once again, and have a great day, and thanks for watching. See you soon. Bye bye.